Okay, this is Feb March 21, paper 52, question 2, the data analysis one where they give you numbers and you plot graph and find the things. So read the question first. A student investigates the collision between two gliders A and B on a linear air track. So you have glider A here, and it's going to whack into glider B. All right. A light gate is connected to a timer. Please observe the light gate. It is floating in mid-air. If you do question 1, you are not allowed to let the light gate float in mid-air. They can do it. You know why? Because Cambridge is the boss. You are not. Okay? So you have to draw it properly. They can just label it. Okay? So there's a light gate here. What will happen is that A will collide with B. And then there's a card L that's attached to glider B. So based on how they write here, this is a very good way to actually measure velocity or something. The mass of the glider B is of the card, and the card is M. Okay, so glider B, everything about glider B, I'm going to highlight blue. Okay, so glider B is initially at rest. So there's a lot of information here that you may or may not need later. Student releases glider A so that it travels at constant velocity U. So this is the constant velocity of glider A towards the stationary glider B. They will then collide and separate. Ooh. The card on glider B passes through the light gate. So by the point in time where this one is here, the card will pass through the light gate. Okay, so when it passes through the light gate, the timing will start here and the timing will stop here. So the stopwatch will start here, the stopwatch will stop here. That's what the light gate does lah. Okay. Student changes the mass of glider B and repeat the experiment. Okay. So, and it records the time t for the card to pass through the light gate for the timer. Okay, it is suggested that the velocity v of glider B as it passes through the light gate and m are related by this equation. So once again, you are given an equation. If you don't know what everything is, you can always write at the side one. U is the initial velocity of A. Okay, m is the mass of glider B, and A is the mass of glider A. So confusing. They use very different way to name masses in this. Okay, never mind. We shall proceed. V is the velocity of glider B. Okay, at least now we know our terms, or if we forget, we can come back here and look at it. A graph is plotted of 1 over V on the y-axis against M on the x-axis. Determine an expression for gradient and y-intercept. How shall we proceed?
Well, you figure out what are you plotting on the axis again. Circle it, underline it, whatever lah. Because that is what you want to rearrange into a straight line equation. So we want 1 over V against M. So you want 1 over V, you flip both sides. I mean, you divide both sides. 1 over, so you flipped it out. Okay, so we have 1 over V on the left, but we need to separate out the M on the right side. So let's break up the fraction. By the way, if you haven't, pause the video, try out this whole question first, because it'll be a bit weird if you have not done the question and you're just staring at those writing equations and all these numbers coming out of thin air. So go try the question, plot the graph, come back, and I will assume that you have already done it and go through assuming that you have done it. Okay. So where we are now, we have M over 2UA. So M is kind of separate. That's good. M multiplied by 2UA. So 1 over 2UA, M. And there's an extra thing at the end, plus 1 over 2u. Now you can recognize this is your linear equation, y equals to mx plus c. So you see y is your 1 over v. Your x is m. Everything else, I mean, whatever is stuck to the m, that is assumed to be gradient. There's a lot of m's here, but never mind, you know the gradient in the y equals mx plus c. And your y-intercept will be 1 over 2u. So just write in there, what is the y-intercept? Okay, so this one, you see, you know how to rearrange and separate out your y-axis and x-axis. And usually if you get correct, it's correct already. Yeah, the working matters. It's just 1 mark.
Correct. Some people, they see immediately, they know. Some people need to actually do this. It's okay, because if you mess this up, then later your calculation will GG. Take your time.
Let's go on to the table. This is where you will need to press lots of calculator. So usually they'll give you a blank spot to write the values and uncertainty. Okay, so if you see the instruction down there, they say calculate and record 1 over v, and they give you an equation to calculate 1 over v down there. Scroll down a bit.
Wait.
Ah. So you will use t over L to calculate 1 over v. Why they put it down here? So don't be like, Miss, there's missing information. No, it's down there. You scroll down and see. And they give you L. So you must remember to divide everything by 5. So t divided by 5 cm. Let's go to the table and do some calculations. So you press calculator, the first value t over 5, you get 0.046. How do you know how many SF to keep? Well, you check t, 2 SF. So your 1 over v can be 2 or 3 SF. 2 SF, 2
Don't forget
SF.
to check your L. 2 SF, 2 SF.
So your final answer can be 2 SF, or if you want to go extra, 3 SF. But it's going to be a plotting pain later, so I'm just going to stick with 2 SF. Because my eyes, when I look at graph, it jumps around, so I'm like, the less decimals, the better. So you just do calculation. Again, I assume you already calculate, so everything divided by 5, t divided by 5, t divided by 5, t divided by 5. Now the tricky part...
This one, can I write 0.08?
No, that is 1 SF. You need 2 SF at least. So put that 0 in. Okay, what else do we need to do? If you scroll down to the instructions, they remind you, include the absolute uncertainty. So you must put a plus minus, find the plus minus. But before you just simply write a number, you might want to think of an identity to calculate your uncertainty. Scroll back up. Let's look at, what shall we use to calculate 1 over v, Miss? How to find?
Of 1 over v. We're going to use percentage uncertainty. So the percentage uncertainty of 1 over v would be, when you calculate v, you took the time divided by the L.
L.
So with 1 over v, you use time divided by L. So time will have its own percentage uncertainty. There, this 0.01 over 0.23, 0.01 over 0.26. And then the length will also have its own percentage uncertainty because it's 0.1 divided by 5. So
Given
I'll just
to
write
us.
this one, del L over L. Okay, then I will substitute or try to write this in a format where I can press my calculator easily. This will be the uncertainty in T. The uncertainty in T is all constant.
0.01. Just write 0.01 now. Minimize error.
Not every year, the absolute uncertainty is constant in your table. Just FYI. They don't always have to be the same thing. But this one it is, which is a good thing for us. Uncertainty for L is 0.1 divided by 5. And then don't forget to multiply the 1 over v. So for the first, I'm just going to do it for the first one, okay? So for the first one, what you will do is you will substitute all this with the values. So the values, I'm going to use a different color. The time is 0.23, and the 1 over v is 0.046. So we press calculator, we got 0.003.
Miss, if you want to put more decimal, can?
Can. But like you say just now, eye pain.
So a good hint actually, if you're not sure, well, one thing you could do is you check your graph. What is the smallest it can plot? Use it as a guideline. Because at the end of the day, the purpose for uncertainty is just to plot it lah. Or you could see your uncertainty match your value in decimal place. Plus minus 1 decimal, okay lor.
Yeah. And later I will show you a sample of some other candidate who wrote more than 1 SF for absolute uncertainty.
Yep. So here is 3 dp, here 3 dp, also can already lah. And so we do 3 dp, 3 dp, 3 dp, 3 dp. So you do press, speed press calculator, pause the video if you haven't, go and do it. Go and press the calculator. And then...
I show them how to use the alpha mode.
What is alpha mode? Oh, well, I guess you could if you want to.
Okay, I'll show.
So anyway...
I find it very useful. And since now we have that calculator app, give me a sec to pull it.
Okay, so here's our magic calculator. It's a bit small, but never mind. You can recognize it if it's similar to yours. Okay, how do we alpha? What's the shortcut?
Okay, so all these purple color numbers, right, are numbers that you want to substitute. Notice that the alpha, I know a bit hard to see, it's red color or pink color, depending on what calculator you use. So I can insert all these pink alphabets inside as my unknown to be substituted. I have two different unknown, 0.23 and 0.046. All right, so in order to use your alpha mode, you observe this equation, and then you're going to type this into your calculator. So, and all the purple numbers, the purple color numbers are your unknowns that you will substitute. Like this 0.23 will be 0.26, 0.31. So I'm going to call this an unknown. So the alpha mode is when you see this red color text or font, you have all this option of A, B, C, D, E, F, X, Y, M. You choose whichever you want. Let's say I choose A. Okay, so you see A will appear. Then you plus 0.1 over 0.35. Sorry, 0.1 over 5. 5.0 is the same, constant, didn't change. And this 0.046 will change with the table values. So I'm going to call this maybe B. And then you tell your calculator, okay, calculator, I input the equation already. Now I want to calculate. CALC is calculate. So you press calculate. The calculator will ask you, hi kid, what is A? So you say, oh, A is 0.23. And then what is B? B is 0.046. Okay, so you get this number. But as usual, if you stare at this, obviously you need to change it to standard form. So what you can do is you could press this ENG mode. You can press, when you press ENG mode the first time, you will get this one. And then if you press Shift ENG, it will move this way. So you can keep pressing. Or if you press, so until this one is 10 to the power of 0, then this will be 0.0029. Rounded to 1 SF, that will be 0.03. So let's do another one again just for practice. Let's say I press calculate. They will ask me again what is A. I test 0.36. So A is 0.36 equal 0, and B is 0.072. Then I press equal. So I get this number. And then I just press the ENG mode, then Shift ENG. I'll get this one, 0.0344. So 0.0344 rounded to 1SF is still 0.003. Okay, so if you do the 2SF option, if you decide to move on the 2SF option, why did we use 1SF again, Miss Ellie? Because we wanted to be able to plot the graph with less headache or pain. But if you decide to use the 2SF option, these are your numbers. Okay. So if you round, then you round.
You round now, you don't round later. And also, it looks nice because the DP of the value and its uncertainty kind of match up. Almost the same. So it's like, well, looks nice.
Yeah. This one, if you see the 666778, is because when I was plotting this graph, I actually had to write down how many boxes they should be. So like this 0.029, all of this, I rounded this one to 0.003. This two is 7 because I round to 0.035. Because the smallest reading that we can get from the graph, let us look at the graph for a bit. So in this graph, right, if you want to find what your smallest available reading is, what we can do is you can just take 0.0. You just see the values, the difference between here to here is 0.005. And then there are like 10 boxes. So it's 0.005. Let me engineering mode again. 0.0005. 3 zeros. So if it's 0.005, all this I can plot to the corner. Because whenever we plot a graph, we want corner plots. So in this case, I can still round 0.0035, 34 and 36 to 0.0035. So I like the fact that my error bars are 666778. But if you round it to 1, then it will be 666688. It's fine. Don't worry about it. Whichever.
So let's go see the graph now. You got all the table, you got the value. You should plot, Miss Lee mentioned just now, plot to corners only. So examiner will zoom in and see, do you put your X in the corner? And they will actually check based on what values you wrote in your table, is this correct or not?
Yeah. So you always have to round to the nearest corner, either round up or round down. Right? So if you look at this 0.034, I round to 0.035 because this is closer to 0.035 compared to 0.03. But if you can save all this headache, if you just
round it off.
0.03 here lah, follow the table value.
Save some pain.
Yes, unless you like pain like me, then you can continue. So the plot corner only.
And correct values.
Correct. Compared to table values. And then you draw your line of best fit based on these plots. This line of best fit, how to know whether a line of best fit is best fit?
So here you see there's this simulation which you can play with. Let's say you have a super ugly set of data. It looks like this. Miss, is this a curve? No. You want to fit a best fit line? Straight line. So the computer has generously fit best fit for us. So Miss Lee, could you check the best fit line, please? Okay.
Pretty.
So how does the computer know to draw this line? Turns out they have a fancy equation way to do it. But we always say that you want the points to be equal amounts above and below the line. And here, you can see it very clearly if we click that residual box. So you see, the points, the amount above the line, those two, are kind of equal to the amounts below the line. So Miss Lee, you want to drag around some points to show how the best fit line would change?
Yeah, so let's say if this one goes lower, then the graph will be steeper. Because now, let's say if it's very low, right, you need a lot of points on top to counterbalance.
To balance out.
Balance out, yes.
So you kind of need to practice lah. Train your eye to balance the amount above and below the line for every point.
Yeah.
Okay.
But I think our graph looks quite nice, right?
Graph is very nice. So you have to look at the very small distance above and below the line to get it
bring your
best fit.
30 cm transparent ruler to your exam. If you don't have, cannot guarantee your examiner can borrow, or your invigilator will be able to find one for you, okay? Then you are on your own now lah. You just, I don't know, use your student ID card to draw.
If you're not sure how long is 30 cm, it should be the length of your arm, roughly.
And the half transparent one will allow you to see the exact position of the plots.
Yes, indeed.
Please buy this ruler.
Yes.
Not sponsored.
Anyway, so best fit line, usually in the mark scheme, they will tell you what I call gates where your line should pass through. And they'll give you the value. So you go and check every paper file you do, you check. So when you get the mark scheme for this one, you can go and check.
We don't have the mark scheme right now, so the gate will normally look like this. It can be a vertical, it can be a horizontal gate.
You just need to go through it to get correct. Yeah. So you said to check your answers. Anyway, so that's a mark for best fit line. What else do we need to know? Error bars and worst fit line.
So if let's say, right, so this one, your best fit is balance or practice if you need to. If you want to draw your error bar, we look at this one, correct? So it's 666, 688. Please, sometimes our CAIE will do the thing where they start with big numbers and then go to small numbers. And then you go and plot your error bar or reverse.
Wrong already.
Please double check whether your points, you start plotting from the bottom or you start plotting from the top. Just make sure you're the correct error bar, okay? So when you sketch an error bar, this 0.046 plus minus 0.03 is plus minus. So if you think about your y-axis, somewhere here, okay, let me zoom in a bit, is 0.046, and then we plus minus law, plus 0.003. So this should be 0.049. Correct? Okay. And then down here, minus 0.003. So this value here would be 0.043. But you don't draw your error bar with double-headed arrow lah. Very weird. So you will draw something like this, and then it will be a straight line passing through the plot.
And it should be symmetrical, because plus minus 0.003 ma. Up by that amount, down by the same amount.
Yeah, so 0.03 is actually 6 boxes. So it's up by 6 box, down by 6 box. Okay? Don't only draw 6 box in the middle. It's not 6 box here to here. It's 12 box in total. 6 box on top, 6 box below.
Let's go see an example down there.
Okay.
Check correct or not? This one should be should be 6 boxes. Looks like 6 boxes to me.
Yeah. So 2, 4, 6, 2, 4, 2, 4, 6. Okay. So you make sure you terminate your error bar. Show where your error bar ends very clearly.
Corners only, no in between boxes.
Yeah. See, also nice all corner.
Okay.
Because we don't know whether you will get marked if it's in between boxes. So please only draw corner. Sometimes you may get marked, I don't know. But if you draw corner, you confirm will get marked. Guess which one I'm banking on? Confirm. I want to have marks. So only corner. So you draw your worst fit line after you draw your error bar. Now, drawing your worst fit line, we are taking extreme values. So you either draw the most possible shallow line within the error bars, which is you take the bottom of the top error bar and you join with the top of the bottom error bar. So if you look at this worst fit line, right, it is shallower than the best fit line. So this is the most shallow line that can still pass all your error bar. Your worst fit line have to pass through your error bar. Another option is to draw a graph where you are drawing the steepest possible line. So the steepest possible line option will look something like this. You take the top and then you join with the bottom
of the other end.
The bottom error bar. So for this particular graph, you can see the worst fit line is steeper than the best fit line. So we are taking extreme values. Ideally, some students will think that, shouldn't we take both and then find the range, half of the range? Yes, but you won't get extra mark for doing that. So we only choose one because
too much time.
It's not worth it. Yeah, it's not worth it. So just choose one. Choose as long as, very important, pass through all the error bars.
Let's write the requirements down.
Okay.
So number 1, steepest or shallowest possible. With the condition that it passes through the main stem of every error bar.
Pass the stem.
Must be stem. Some say, Miss, I pass the side of the error bar. Cannot. Must be the main stem.
You cannot draw like that. This one don't count.
Must pass the main.
Pass the main like this. Okay. Make sure you label. No label is very nice one. When I mark student never label, I give 0 out of 2.
Which line is which line? Excuse me.
Yes, this label. I do not recommend drawing broken line, although they say that they allow this in the syllabus, because when you draw your triangle to find gradient, you already draw broken line. You got too many broken line, then your concentration also broken. So leave the broken line or the dotted line for the right angle triangle that you will use to find gradient. Your error bar, by the way, must be symmetrical, okay? Correct, of course. If not correct, then
following your table.
Follow your table. Okay, so when finding gradient, the first thing I see is big triangle. Triangle must be at least half the hypotenuse of the graph. You can be a bit smart and draw one big triangle and then just use the cutoff points here to here. But you can see this student will probably have to take a in-between plot. So if like this, how Miss can read in between boxes?
No,
we
I
round
don't.
Up, right? We round
up
up to 0.08. Okay? But for me, you can see I am a person that always think too much one. I rather draw 2 triangles and I make sure I only take corner plots that lie perfectly on the line. Corner plot, corner plot. That's me. But then I will have 2 triangles and I have more things to do. Just like I took 2 SF and then I got more things to do. Up to you. Okay? So just make sure you read and only read corner values only just to be sure. Generally, we would recommend writing the coordinates. It's not compulsory, but if you write, it will help you double check your answer. It will also help the examiner.
Yeah, you can check much quicker. Anyway.
Then let's put in the values. What is the values for your triangle?
You need to find gradient and you find uncertainty. So we need to find gradient of the best fit and the worst fit. So firstly, we're going to find the gradient of the best fit. So you write your working lah, just write and best. Like then you, whatever 2 points you have, y2 minus y1. So in this case would be 840, 0.0490.
So these are based on the graph that we have drawn. We include the units y.
It's a good practice, I think.
Mm-hmm.
So,
You can double check lah. Because later sometimes they ask for units and then you go like GG, what is the unit?
Never mind. Okay, so you do once for best fit. Do again to find the gradient of your worst fit. So make sure you have, you should have different values. If you get the same value, something is wrong already lah. So that will be also the same unit as well lah. But we don't need to write that. So this will be 6.15 times 10 negative 5. Okay, when you want to find uncertainty, you just minus both. It is already half the range.
We assume
best
it's symmetrical.
minus worst is half the range already. So you get a value, and that will be your uncertainty. So when you want to write answer, or you got so many prefix, what you can do is write it in standard form. So you choose your best fit line first, and you write it in the answer line. 7.45. Then you plus minus your uncertainty, 1.30. Then you close the bracket and you write your prefix. This is what we call standard form. And just for good measure, might as well write your units down as well. They
Yes,
won't
do I-
minus if
How
you don't
many
write.
SF? Can
You can write, same or one more SF than your graph values. Usually
So if
2 to
let's
3.
say-
Usually.
Yeah. If let's say you don't like this because it makes you feel uncomfortable, so many SF, this is also okay.
Mm-hmm.
Okay. So if you're watching this and the FM21 mark scheme has not been published, so you don't know whether your best fit line is correct or not, your gradient should be around this number, 7.5 times 10 to the power negative 5. The alternate working that I did, my gradient rounded to 2SF is also 7.5. Mine is 7.54, and this person's one is 7.45. Close enough. Okay, but because I use the steepest possible line, so my gradient of worst fit is bigger and my absolute uncertainty is smaller. Okay, so the reason why absolute uncertainty is smaller, just so you know, is because you can see these two lines are closer to each other compared to these two lines. They are slightly further apart due to the distribution of the point. So don't worry about it. It doesn't matter. You just choose whatever one of it and do.
They're
So my
checking your
absolute
method
uncertainty
lah.
is 1. Yeah, doesn't matter. They are checking your method. So the 2 mark here, 1 mark is for triangle, gradient correct coordinate substitution leading to the correct answer. This is 1 mark. The second mark is when you find the gradient of the worst fit line, use the right method, modulus. That would be the second mark. 2 mark only. You make one mistake, then it's 0 already. It's a do or die question. You don't show any important working straight away, GG. Okay, y-intercept. Include absolute uncertainty. This question never
Miss
ends.
can read from graph, y-intercept.
Let me look at the graph first.
Cut the graph there, ma. You just cut there, can read already, ma. This y-intercept is there, ma, right?
But your axis can start from 0.
Y-intercept occurs when x is 0. Oh, yes. Also cannot read from graph.
Yeah.
No, cannot. So you need to calculate with your beautiful famous straight line equation, y equals to mx plus c. So we gotta rearrange it lah, because you want to find the intercept, right? So you'll be using
so
c,
best fit line.
y minus mx.
Then we repeat again for worst fit line.
You know why? Because later we have to find uncertainty. So you take best minus worst. Never mind, we find best fit first.
Okay.
So you need to pick some point on your graph. You could reuse your gradient points. It's just convenient.
Okay.
So let's just do that.
0.0840 minus 7.45 times 10 to the power negative 5, 790. So this is the coordinate.
From your graph.
The line, yes, the best fit line passes 790, 0.0840. Write this if it helps you adjust your brain. So this one would be 0.0251. Then we do again for worst fit line.
But you must use worst fit gradient.
Oh. And
Y
the
equals
coordinate
mx.
also worst fit
Worst fit.
coordinate.
Yeah, you must change the coordinate. So from the graph, it's a bit different, no? Your values will be different. Worst fit coordinate, worst fit gradient. So now you have two intercept. If you want to find the uncertainty, what do you do?
Oh, I know. Modulus minus.
Yeah. So it doesn't matter which one is, just minus both. Take away the minus sign.
Because if I feel that my working is all over the place, I want to help the examiner immediately give me mark 1. So I will write the equation. To trick the examiner to think that I know what I'm doing.
Yes. It's a good practice.
Then after a while, my student will tell me, Miss, you always know what you're doing. You fake one. So because I mark when I mark, I see this, I happy. I give C1.
I agree.
Yeah, I want you just write that line. My life is easy. Your mark is easy. Everybody easy. Okay. So the final form of the y-intercept will be 0.0251 plus minus 0. Miss need to write prefix this one.
Prefix can if you want to lah. If you want to, can. They are not too strict about it.
What unit though?
They didn't ask for unit, but we could write units. Unit, you check your graph.
Copy this one.
Y-intercept is the same unit as your y-axis because they cut the y-axis at a certain value. So you can just write.
So next part, using your answers in all the previous parts of the question, find U and A. Wow. Include appropriate units.
Now this is when you need to scroll all the way back to the beginning and look at where is U and A in your, how does it relate to your graph? Gradient, intercept. Oh, this is good. We should crop this.
Miss, I got students sometimes, they do simultaneous equation there. You can
I don't. It's supposed to be easy thing. You're supposed to just plug in values, what you have, and just find the values. So you rewrite the same thing, no? Gradient equals to. Wait, we don't have U and A. Maybe we should start with the intercept first.
Okay. Why?
Because intercept only got one unknown. We find U first, ma. So why you write there?
U to find A.
Yes, correct. Very clever. Okay, we find 1/2U. You write this step, you must write out the working, so it's very clear that you know what to use instead of just a bunch of numbers everywhere. So you write out your y-intercept equals to 1/2U, and you write out what is the value of U. Generally, 2 to 3 SF is safe for your answers. But unit, what is U? There are a few ways to do this. The first way, which is the shortcut, is to scroll to the beginning and see what is U. What quantity is it? Is it something that we know? Let's read the thing again. U is constant velocity.
Initial velocity.
Velocity, what is velocity? Normally we say meter per second. But hang on a second. This is in cm. So cm per second.
Because 1/v is second per cm. Okay.
So cm s -1.
Yeah.
The longer method is to do what you do in AS. One by one, you calculate what's the unit.
The longer one would be, you think about this 1 over this 0.0251 is second cm -1. So you inherit the unit here, no?
But inverted.
Then you invert the unit, so you get this one. Okay.
Next. So now we got U already. We can do the gradient one. So you write again. Gradient equals to 1/2UA. Rearrange everything. What is A now? A equals to 1/2U gradient. And we plug in everything we know. Just do some working. I think we can delete the little box at the side now. Bye-bye. There we go. And we got 1/2. Plug in your U and gradient.
Gradient of best fit line, okay?
Using best fit line, yes, correct.
You use best fit line for both values.
So you press calculator correctly, you should get a value of about 337. And what unit is this? What is A?
We can do the painful process again, or we can just what is A?
If you know what is A.
Mass of glider, kg.
Grams, miss.
See, how did we measure mass in this experiment?
All in grams.
Did we convert gram to kg at any point? No. In our calculation? No. So it's gram. If not, then you can just, repeat the whole process again.
So again, 2, 3 SF is kind of in a safe zone. Sometimes they will give marks for SF, but we'll see. This one looks... They might give a range or so, something that is allowed range. But we don't know. It depends on the mood of the setter.
So generally, 1 mark is for unit. 1 mark is for method. Method that we're talking about is you use the y-intercept to find u. You use the gradient to find a. I see very clear substitution from y-intercept and gradient to the constant u and a. The other one, besides method, sometimes they have a range. So this is what Miss Ellie meant by, we don't know whether they go put range. But
maybe
the numbers make sense.
they say only can have around 300 to 400 grams or something like that. Maybe, we don't know. Anyway.
Yeah. But these numbers make sense, okay? If your numbers don't make sense, you mess up now. Go check something is wrong. Because if you get your trolley like 337 kg or
so heavy, cannot.
in the lab,
No.
or if your speed is 1990 cm per second,
Too
second
fast.
you travel 19 meter, wow, faster than Usain Bolt.
Cannot be. So you can do some physical reality checks. Percentage
That's why-
uncertainty. Let's go.
That's why, by the way, that's why they ask you to
Oh, yes.
estimate
yes.
numbers in your AS lah.
So
So that
we
it develops your instinct, but don't know whether it's working.
maybe can or not. Don't know. We check and see first lah. Okay. So we got equation for A already. We need to see what contributes to the uncertainty in A. There's U, and there's also gradient. We got uncertainty for U meh? We got calculate meh?
Got meh?
Don't have Then we check, U is calculated from where?
U is from y-intercept.
So y-intercept got uncertainty, yes, that one got. So maybe we change a bit. It means y multiply together, shouldn't add delta U over U plus delta gradient over gradient.
Alright.
This one will be y-intercept over intercept plus A. Move that one there. I guess you could move it there. Y-intercept over y-intercept. This one.
We're taking percentage uncertainties. Okay, so you reverse, you flip back and you take this divided by this
Take your values.
plus whatever value you get this divided by this. So that would be 0.0073 divided by 0.0251 plus 1.30 divided by 7.45 times 100% now.
So this is percentage in A.
47%.
This
So
pretty
this
big.
1 mark is from this calculation. We need to see this identity. So just make it a habit to write this. But if you don't write this and you divide correctly, marks will not be deducted. It's just that now I have to double check and confirm. So what I want is, let's say maybe the examiner is rushing and they see that I know the right identity. They don't check my substitution. In case I copy number wrongly, if you watch enough of my videos, you know I always make transfer error, right? So write the equation. Okay, last part. What do? We repeat the experiment.
So in the last part, usually they will ask you to calculate something. You already know all this stuff that you just found, hopefully. Now you have to use those to calculate. So you list what information did they give you?
You want to find M. T is 0.50. Can I just use what do? Do we use the equation?
If you're not sure what to do, you scroll all the way back to the top and you rewrite the linearized equation. Just write it down first. Just stay calm and write it down.
You mean this one?
Yes, correct. You paste there first lah. Then we'll stare at it what to do. The students usually come to this part, they're like panic already, like, wow, I don't know what to do, how to find. Am I supposed to use some fancy theory?
Simultaneous equation.
No. We are not doing physics theory here. We are just doing press calculator exercise. So we look at the equation there. Maybe we rewrite it in terms of gradient and intercept. So we'll have 1 over V equals to, just now we already say 1 over 2 UA is gradient. So we just write that out, gradient times your x value, or m, which is what we want to find, plus y-intercept. So the x is the m now, so maybe we write there as m. Gradient times m.
I also have gradient already.
If you know gradient, 7.45, just write it there. Right first. Then the mass, we don't know. Just write there m lah. The y-intercept we do have from earlier, so just write whatever y-intercept you have. Now we look at the stuff we don't know. 1 over v. We got 1 over v meh? They got give v meh?
But they give this one.
Oh, 1 over v is t over l. Okay, we substitute inside there t over l.
Then
t
the
is
L
given.
is the same cut, right?
L is given. So substitute t over l in 1 over v. Plug in all the values we know.
5 cm. Need to convert.
I mean, everything is calculated in cm lah, so we stick with cm. You cm all the way.
If you have never converted anything until this point, you shouldn't randomly start converting. Okay, and there's a reason why they ask you to write the units here, to remind you this is in cm. So all the doubts in your head, hopefully with units and with practice, you'll be okay.
But if you did in meters, then you meters. You must know you're in meters lah.
Yeah.
cm, meters.
Basically, you have to have awareness about the units that the current experiment is using. Okay, so if we press the calculator, we will get 1,005 grams. Does this number make sense?
1 kg for a, what is this? Glider B. Seems okay.
Yeah.
1 kg is still reasonable. Estimate your quantity. You can write 1,000, you can write 1,005. Here usually 2, 3 SF also, same rule of thumb, generally okay.
Yeah, they're looking for method so that you substitute this, the correct value of t, and then you look for m lah, using the linearized format. Okay, so this is one way. Another way that students can do this is, instead of using the linearized equation, they could use this equation.
The original
One, because don't forget, you have already used the graph to find u and a. So this is the original equation. And what you could do is v is equal to 2ua over m plus a. But you should know that v is equal to l over t lah. Right? So you can substitute this one, 5 cm divided by 0.50. So this is 10. Okay, and then this will be 10 is equal to 2. We have u. What is u? 19.9. A is 337. M plus 337.
Press calculator.
So you can just press calculator like that. Just choose one method and don't get confused. Okay, because if you choose, I mean, if let's say you finish the paper very easy, you finish question 1 already, you don't know what to do yourself, then you can always just go back and try a different method just to double check and make sure the answer is correct.
Can do 2 methods to check one answer. Wow.
1004.26. Okay, I am happy.
A little bit different.
Enough. But to be expected, what? When we find u and a, we did some rounding. What? Okay, so these are all okay. The important part is you must show the substitution that you do. What substitution? You should be able to clearly see what you substitute. Okay, that's it. Any parting thoughts for paper 5? What kind of strategies?
Go and practice question. That's the only strategy here.
Question. Know your strengths and weaknesses and do the more confident question first. And be mindful about time. Because you only have 1 hour, 15 minutes, I would suggest spending no more than half an hour in a question. So you got 15 minutes to flip things around and daydream and contemplate about the meaning of life. Okay, that's it. I'll see you.
Okay, so that's all for this video lah. Go try out some more paper 5s. We'll see you in the next video. Bye bye.